Hello and welcome to my presentation of my final Android project. I decided to create a lightweight pedometer application that stores and runs completely locally on your Android device for privacy reasons. A lot of pedometers that are on the App Store today, or Play Store, they normally rely on some sort of database or cloud database, or sometimes some sort of satellite implementation or some sort of implementation from Google. So I decided to make a lightweight pedometer that only uses the sensors that you can normally find on your normal Android device. But before checking out my application, I just want to make sure that I give the proper credits to the creators for the GitHub code that I heavily got influenced by. So we can see that if I just remove this phone here, we have this creator J4 Velin or Javelin, and he has an amazing GitHub page where you can recreate what I did here, or even take it beyond, and you can contribute to this project too. You can see here there's 26 people contributing. And if we take a look on his implementation, he has some screenshots here, and he uses also another library for these visuals that I also used for my project. And taking a look at his actual code, we first want to take a look at the manifest and go to services. And we can see here that we call something called a sensor listener. So let's take a look at the sensor listener, because that is really the meat and bones of this project. And in here we have a class that implements the sensor event listener, and on when the sensor changes, when a new value is detected, we will run this update if necessary function that updates your database. So all the data, all your steps, and all the previous days and months, and all your hard work out there in the trails will be stored on your local database. And if it's necessary to update the values that the sensor receives, it will put that in the database. So let's see how I implemented his code into my project. So his project normally uses fragments, and since we haven't used fragments in class, I thought it was more appropriate to translate it over to activities. So his implementation had to be changed slightly, and I also split it up to fit my needs and to fit my design preferences. So my application, as you can see, has these different layouts here that pretty much does what his app does, but in different activities. And taking a look in the main activity, we can see that it also implements the on-sensor listener that is said if ISO walk around, we will update a text view, and also something called a pie model, which is from the custom library I was mentioning earlier. And that value is stored in the database again. So I've been mentioning the database a lot, and let's actually take a look at the database. So the database, as we can see here, is an SQLite database. And what it really does is let's see if we can find it. Yeah, so this is a good, no, never mind. Where is it? Yeah, so here we can see it inserts data in days. So you can have some sort of a graph or history over your previous inputs into database, and we can create some nice looking graphs with that and see how your progresses or how much you actually are out there in the tracks or out there walking around. So that's enough of the code, in my opinion. Let's actually take a look at the application here. So this is on my actual physical device, and this is the application here. We can see that he had a widget implementation here that shows my current progress. And if we actually open the app, we have this this progression bar, this pie chart that I was mentioning earlier. And if we click on it, it has an on-click listener that will change it to the distance. And if we go over to the graph of my previous workouts or my previous activities walking around with this the past few days, we can see that I haven't been very active during the corona crisis here, but at least the code works, and the rest is on me, I guess. Another cool function that I implemented was this ability to split your steps if you want to make sure that, okay, I want to measure how far I walked on this particular walk. You can split the steps. So if we go back to the original view, the main view, we can see that it has a few more steps than this. And we can just simply split it, and it will keep this number independent of the other number, and it will just reset to 0. And there, in that way, you can make sure that you have an accurate representation of an actual like activity compared to maybe you just walking around, or maybe you just, I don't know, walking around town. Then we have some preferences or settings we can adjust that the user can. I mean, not everyone has the same step length, so you can change your step length. Let's do inches for this time, and let's say we have like a 10-inch step for some reason, and let's say we are a very active person and we want to have maybe 11,000 as our daily goal. If we save this now and go back to the original view, we can see that our goal has been updated. And also if we hit the on-click listener, it changes over to miles, and it changes over dependent on how or what unit you selected, if it's in the metric system or the imperial system. The distance is also calculated given your stride length. And then finally we have the about section, which pretty much just says, okay, this is an app created by me. It was an app made for the university, and special thanks to the GitHub creator of this project.